So today we're going to be talking about non-negative or integer or positive integer solutions. So this is the grouping rule. So you can arrange, say let's have numbers 1, 2, 3, 4, 5, and 6. You can arrange those in 6 factorial ways. So basically if you have like n different objects, the number of ways you can arrange them is n factorial. But let's say we have 1, 1, 2 1s, and 4 2s. So that's also 6 factorial, but you also have to divide it by 4 factorial and 2 factorial because there are 4 2s and 2 1s. So say you have 2 1s, 2 2s, and 2 3s. It's going to be 6 factorial divided by 2 factorial 3 times. And again, if you have 1 1 but 5 2s, it's just 6 factorial times 1 factorial times 5 factorial. So generally, if there are n different objects, you can divide them into R groups, A1 plus A2 plus A3 all the way up to AR. And so there have to be n1 objects in group A1, n2 objects in group A2, and just nr objects generally for the group AR. And n1 plus n2 plus n3, they have to add up to n. So the number of ways you can arrange these numbers is n factorial divided by n1 factorial divided by n2 factorial all the way up to nr factorial. So essentially, just divide it if they're like any, for example, again, you can see here, you have like 6 factorial for the number of digits, but you can see some numbers repeat more than once. Just divide it by the factorial of how many times these number repeats. So if you have n distinct balls in m labeled boxes, and the number of balls in each box is not limited, the number of ways you can put them in the balls into the boxes is m to the n. So they don't have to always be balls in boxes. They can just be any n distinct objects in m distinct groups that you can arrange them in. So here's an example. So it's how many 7-letter words can you create by rearranging the letters of lettuce. So you can see this has 7 letters, so it's 7 factorial. However, you can see that this T repeats twice, and also this E repeats twice. So you can divide it by 2 factorial times 2 factorial. So this is going to come out to be 7 times 6. So this is going to cancel out, and you're going to get 1,260 as your answer for how many 7-letter words you can create by rearranging the letters of lettuce. So let's say there are 3 people. Their names can be Annie, Aaron, and Rainer. So they all want cupcakes. And there are 8 total cupcakes, but they're all different flavors. So like one of them might be vanilla, one of them might be chocolate. I don't know. They're just all different. So how many ways can you distribute these cupcakes among these 3 people? So we can think of Annie, Aaron, and Rainer as our boxes here, our distinct boxes or groups. So that's going to be our M. And there are 8 cupcakes, and they're all different. So we can think of this as our 8 distinct balls. So N. So remember the way to arrange to put n distinct balls into m distinct boxes is m to the n. And so there are 3 boxes here. So that's just 3 to the 8, which is equal to 6. Right. Okay, so that should be it for this unit.